Now we're going to look at section 6.5, inserting and removing the existential quantifier. So, as we saw last class, we use weak generalization and the specialization rule to insert and remove the universal quantifier. So now we're going to look at the dual of those two processes. So I've mentioned the term dual before, and when we say the dual, it just means that because the universal quantifier and the existential quantifier are sort of opposites of one another, right? We get one by taking the negation of the other. The dual gives us the equivalent statement with the other quantifier. So because the universal quantifier is the quantifier we're using as our main quantifier in our logic, when we're looking at equivalent statements involving the existential quantifier, we call these statements the dual. So our first learning outcome is to use the dual of the specialization rule in theorem calculations. So the equivalent specialization rule for the existential quantifier. And we're also going to use something called the auxiliary variable metatheorem, or AVM for short, in theorem calculations. So these two work like weak generalization and specialization to be able to add in the existential quantifier and to remove it in our proofs. Okay, so we're going to begin by looking at the dual of the specialization rule, or the equivalent statement of specialization rule using the existential quantifier. So again, because universal quantifier and the existential quantifier are opposites, we're going to get something a little bit different. So let's first look at the dual of axiom AX2. So remember, axiom AX2 involves the universal quantifier, and it gives us the reverse direction. So it allows us to say for all xa implies a particular instance of A. So now, because these are the opposites, we have the opposite direction. So this dual of AX2 says if we have a particular instance of A, then we know there exists some x where A holds, in particular T, I suppose, in this case. Okay, so that's what the dual of that axiom AX2 says. And then, of course, the dual specialization comes from this axiom, just like the specialization rule came from axiom AX2. Right, so it says that if we have a particular instance of A, right, so A where we replace T by X, so some particular example of A, then we can conclude or add in the existential quantifier with respect to a variable X to A. Right, so this allows us to add in the existential quantifier. And again, we have a more simplified and more useful, in some cases, corollary to this, which is wherever we see A in the proof, we can add in the existential quantifier in front of it. And here notice that there are no conditions on which we can add in this particular quantifier. Okay, so this allows us to add in the existential quantifier. And now, by looking at the ability to add in both the universal and existential quantifier, we have a couple of meta-theorems which involve some additional conditions. So first meta-theorem allows us to introduce the universal quantifier into an implication. So there are some conditions in this case. So if X does not occur free either in the set of hypotheses gamma or in the formula A itself, then we know that gamma proves A implies B if and only if gamma proves A implies for all xb. So this allows us to add in a universal quantifier to the conclusion so long as X doesn't occur free in gamma and A. So when we have A implies B, we're allowed to add in this quantifier under these particular conditions. So the dual of this meta-theorem is the introduction of the existential quantifier, and again, a few things are a bit different. So again, we have conditions. So if X does not occur free either in gamma or in B, in this case, then gamma proves A implies B if and only if gamma proves there exists XA implies B. So here we're allowed to add in the existential quantifier into an implication if it holds, so long as X doesn't occur free in either gamma or B. Okay, so we'll look at an application actually of the dual of specialization in the next video, when we also look at the auxiliary variable metatheorem and how we can remove this existential quantifier in our proofs. And as you can imagine, there are some conditions under which we can do this.